Welcome back, everybody. Section 12.3, Day 2, Arithmetic Series today. Now, behind me, you can see that I've got an arithmetic sequence written on the board. Again, keeping in mind that an arithmetic sequence has a common difference. So in this particular arithmetic sequence, 7, 3, -1, -5, we would see a common difference of -4. What's the arithmetic series look like? We don't want to overthink it. I'm still going to use the 7, the 3, the -1, the -5, and so forth. But again, what's the difference between a sequence and series? The series, you're just adding the terms. So 7 plus 3 plus -1 plus -5 plus on forever. Now, again, with an arithmetic series, because you have a common difference of some sort, there's literally not going to be a sum that you can have of an infinite arithmetic series. You'd die trying to get it all done. You'd never get there. But there are partial sums here. Now, let's say that we were to take a look at a different series. So again, arithmetic sequence, the terms. Arithmetic series, you're adding the terms, the only difference to them. Now, one thing that we can't forget, because we are dealing with an arithmetic sequence, or the terms of an arithmetic sequence, that explicit form for those terms that we had from day 1, a sub n is equal to a sub 1 plus n minus 1 times d, will still be utilized a lot. So we can't forget that. So one of the things that I always suggest in any problems that we have moving forward is to write that formula down. Now, we're going to take a look at an example here. Where we're going to be asked to say, find s sub 7. Now again, s sub 7, the sum of the first 7 terms of a series, let's say, that is running 13 plus 21 plus 29 plus 37, and that continues on. Now, because we've got 4 terms here already, we can probably do this one pretty much straight out. So if we were to write out the next 3 terms, okay, the first thing I want to recognize, what's the common difference here? So 21 minus 13, and then we'll verify it. That looks like 8. So let's see if that's matching. 21 plus 8 is 29. 29 plus 8 is 37. So yeah, that's working. So we have 13 plus 21 plus 29 plus 37. There's a sub 4. We need to get all the way to the 7th term. So let's generate the last 3 positions. All right, now keeping in mind this goes on forever, we're only needing the first 7. So 37 plus 8 is 45. 45 plus 8 is 53. 53 plus 8 is 61. Now, we only have 8 terms here, or excuse me, 7 terms. Now that's not too hard to add together, okay? We could do that on a calculator, okay? And again, I'm not going to do this mentally. I probably could get it done, but I'm going to go ahead and get a calculator on this. So I'm going to do 13 plus 21 plus 29 plus 37 plus 45 plus 53 plus 61. And I'm going to get my total of 259. Okay, so nothing real major there. Now, assuming that I've typed everything in correct, okay? Now, what if you had to do this, though, for, let's say, 50 terms or 100 terms? Would you want to have to write them all out and try to calculate by adding and adding and adding? No, I don't think we would, okay? So what happens, or what is somewhat unique about an arithmetic series, is that some different things occur. Now, we can already tell. I'm going to go ahead and write this, that we know that S sub 7 is equal to 259. We've found that here. Okay, now again, that's assuming I've done my math correct, that I typed it in correctly. So let's play with this a little bit. Let's take these same 7 terms here. Okay, and let's just say, because I can do something with it, let's say I'm going to take this same series, S sub 7, and I'm going to add it to the series that I already have here. Okay, so I'm going to use S sub 7 a second time, except instead of writing 13, 21, 29, 37 in that order, I'm going to flip it all the way around. I'm going to write the 61 here, and the 53 here, and the 45 here. Basically, I'm flipping the entire series backwards. Now, you might be thinking of that, okay, big deal, Mr. Varsh, it's still going to be the same thing, but if you're adding it, you're just making it twice as large. Yeah, but we want to see some patterns out of this. So I'm going to go ahead and add these together here. So notice that this S sub 7 plus S sub 7, we could say is 2 times S sub 7. Okay. And now I'm going to perform these little additions here. We're going to look and see what happens here. What's 13 plus 61? Well, that's going to be 74. 21 plus 53. Another 74. 29 plus 45. 74. In fact, by turning this around and adding it, I'm just taking the same terms, adding them to themselves, but in an opposite order, I end up creating the same value every single time. So take a look at it from a bigger perspective out of this. How many 74s do we have written out? 1, 2, 3, 4, 5, 6, and 7. So that's like 7 times 74 is 2 times S sub 7. Well, that would mean that S sub 7, if I needed to get the sum, would be 7 divided by 2 times 74. Now, you might be looking at me going, okay, Mr. Varsh, big deal. You're just playing with some numbers and coming up with a different look. Well, yes, I am. But here's what I want us to concentrate on. If the 74 is being generated every single time, I can concentrate on that idea using the first and the last terms of the original series, A sub 1 and A sub 7. That 74 is being generated by using 13 and 61. So what that's allowing me to say out of this down here is that I can essentially say that the sum of those 7 terms is 7 over 2, and the 74 is generated by the 13 plus the 61. Now, let's look at the pieces a little bit more carefully. Here's a 7. There's a 7. 13 is A sub 1. 61 is A sub 7. It kind of looks like here's an n value. There's an n value. And there's an n value. So what we get out of this, everybody, is a nice compact formula that if I extended this to any number of terms, n number of terms, so to speak, I can modify what I see here. So S sub n would be n over 2 times the addition of a sub 1 plus a sub n. So notice again, I'm relating back to the term number. So what we have then is we now have a way of calculating the terms of an arithmetic sequence when they're being added, the arithmetic series. So now we have the terms for the sequence, but now we get to add to that, and that we now have the sum of the series. Now keep in mind, this is all arithmetic here. So the sum of the series, S sub n, is equal to n over 2 times the addition of a sub 1 plus a sub n. So now, everything that I do today is going to revolve around those two formulas. I just need to know which formula I need to use when. So looking ahead, that this allows us then for any partial arithmetic series, we can get its sum if we know the number of terms, we have the first term, and the last term. Now keep in mind, that's where this first formula comes in. We might only get partial information. So we're maybe going to need to generate information in order to figure out the sum, or we might be asked to find a certain term given a couple of pieces of information from the sum. So they're going to mix these two up a little bit, and we're going to be utilizing them over and over and over. So you can't let the sum formula go and the arithmetic sequence formula go. They're going to work hand in hand here. Here's an example. Let's say, so if we start looking at some examples, let's say it asks us to find S sub 18 for this particular sequence. Let's say they give us 9 plus negative 2 plus negative 13. Okay? Now you notice they're only giving us 3 terms of this series. So if I need S sub 18, I'm going to need some missing pieces here. So what I want to recognize out of this sequence or out of this series, I want to see what I can recognize. Okay? So think of the pieces that we need to find. Or maybe better stated, not what we need to find, what do we have? We have a sub 1, which is 9. Because we have an arithmetic series here, okay, so we are arithmetic here, we can also figure out the common difference. Just because it's written in a series doesn't mean the sequence goes away. So I can still find the value of D, negative 2 minus 9, which is negative 11. Now, here is where I suggest having both formulas. Because look at what we have. We've got a sub 1 and we have D. Okay? So I'm just going to highlight that. Now, so I've got a sub 1. I've got D. Now here's what I'm going to do. I'm going to write out both formulas side by side. A sub n is equal to a sub 1 plus n minus 1 times d. And I'm not going to be quite on the same line here. S sub n is equal to n over 2 a sub 1 plus a sub n. Now, let your observation of information help you through the problem. We need to find what? S sub 18, don't we? So if I continue going down the line with what we have here, think of all the pieces we don't have yet. Okay? In order for the formula to work, to find S sub 18, I would have to recognize out of this that for S sub 18, I'd have to have 18 over 2, a sub 1 plus a sub 18. Okay, so if I need S of 18, that means I need n. That's 18. Okay, so that's just coming from here. So now take a look at the information. Over here, yes, I could put in a sub 1. Okay, so if I put a sub 1 in there, 18 over 2 I can write as 9. A sub 1 is 9 itself. Notice I'm kind of stuck. What don't I have? I don't have a sub 18. Can I get it though? Absolutely, I can get it. This is why these two formulas go hand in hand. I can find a sub 18 because a sub 1 is 9. My n value has to be 18. And I know my common difference of negative 11. This is what always will have to happen. If you write both formulas down, whatever given information you have is either going to let you get something from the sum, or you're going to get something from the sequence piece. Somewhere along the lines, it will give you a piece of information. In this case, notice when I put everything in, it's the explicit formula for the certain terms of a sequence that allows me to figure out S sub 18 or A sub 18, which that value then write in for the sum. So notice there will be a pattern that develops out of these. If you put them down together and you fill in the information that you have, it'll show you visually where you can go. So here we are, 9 plus, what is that, 17 times negative 11. So 9, that's going to be a subtraction of, what do we got, 187? If I've done my math correct there. So 9 minus 187 looks like it's going to be a negative, let's just do that, 187 minus 9 to play safe. 17 minus 9 is 8. 17 minus 9 is 8. Oops, excuse me, let's do that again. 17 minus 9 is 8. 178, but negative. Notice, where do I get to use that now? Using these two formulas simultaneously, filling in what you can, will give you the missing piece from one to the other. So notice, I can take that 178 now, and I can put it in. So S sub 18 is equal to 9 times 9 minus the 178. So now we're just ready to calculate. So 178 looks like we're going to subtract 9 there, so that's going to be 169. But a negative number. Okay, 18 minus 9 is 9, 169. So now we're just ready to do that final math. Save a little time here. 169 times 9. And we get a negative 1,521. So literally, everybody, anything you do off of this particular section will almost always involve using both of these formulas. The explicit form for the explicit rule for the arithmetic sequence, and now the formula for the sum of a partial arithmetic series. Now, they're going to give us information in different ways. Okay, so we're still going to be finding some sums of arithmetic series, but keep in mind another way that we wrote arithmetic series, or basically any series. They could give us an example where we are in summation notation, where let's say they start with k is equal to 1 all the way up to 18. Excuse me, let's go to 15. I'm sorry, miswrite on my part. And they give us 5 plus 2k. Now, keep in mind that if I write down the two formulas again, a sub n is equal to a sub 1 plus n minus 1 times d. S sub n is equal to n over 2 times a sub 1 plus a sub n. Now, sometimes I may need both. Sometimes I only need one of them. Let's see what I can figure out from the information. So again, I don't want to just look at this and stare at it and think, okay, I don't know where to go, Mr. Varsht. I get that. What can you do with this? Well, let's consider the number of terms. From yesterday's material, or from the previous day, section 12.2, 15 minus 1. Top minus bottom plus 1, we've got 15 terms. So what does that tell us? That tells us essentially our n value here. Okay? What else can we now find then? These values get plugged in, but what do I need? So if I know n is 15, that's telling me in this formula here, I'm looking for s sub 15. So I can say 15 over 2, a sub 1 plus a sub 15. So what's still missing? A sub 1 and a sub 15. Can I get that? Absolutely. I can utilize the summation and finding the first term by plugging in the 1 and find the 15th term by plugging in the 15. So I can get there relatively quick. A sub 1 is going to be equal to 5 plus 2 times 1. 5 plus 2 is 7. Now let's go a sub 15. A sub 15 is going to be 5 plus 2 times 15. So 5 plus 30 and gives us a 35. So notice, now I generated a sub 1, I generated a sub 15. I'm there. So I actually didn't need the second series, or the second formula here in this particular case. So, doing a little math, 7 plus 35 looks like 42. I'm just going to continue to clean this up. Many of you, I know, you'd go to a calculator, you'd finish it off. I'm going to suggest you keep it exact, because if you go to a decimal here and you round it off, that is not an exact sum. So keep it in fraction form. So 42 divided by 2, that's going to be 24. Now this one is set to work out perfectly here. Again, if you've got some that have decimals, it would probably designate what to round it to. I would make sure of that. But any case, default to fraction form when needed. So 15 times 24, and we got 360. I'm hoping you're thinking that's a heck of a lot better than coming up with all 15 terms and then adding them, okay? Because you only need what? The first term, the last term, and the number of terms. And you can calculate the sum of the arithmetic series. Okay? Your turn. Let's say you're looking for this. Find S sub 16 for the series that we have is 12 plus 7 plus 2 plus negative 3 and so forth. Pause the video. Go. Here we go, everybody. So in this particular case, again, I want to identify the different pieces of information that I have. So in this information from the series, I know that I need 16. Okay, I know the number of terms is 16. A sub 1, I've got is 12. D, hopefully you could agree, is negative 5. Okay, a little mental math again. 2 consecutive terms, do the subtraction. In order to do the sum, though, that means I need a sub 16. That's the piece I don't have. So again, if I write down both formulas, I can fill in the information that I do have. Okay, so I'm looking at S sub 16. So 16 over 2. A sub 1 is 12. A sub 16 I don't have. So there's a little work I can do here, but I'm missing a sub 16. That tells me check the other formula. Okay, so I come over here, a sub 16, a sub 1, which is 12, n, which is 16, and d is negative 5. So look at what you get. You get a sub 16. So doing the math, 12 plus what ends up 15 times negative 5, which is 12 minus 75, which is going to be a negative 63. Okay. Now I've got my a sub 16 that I can put in here. So S sub 16, 16 over 2, I'm just going to go ahead and do that division of 8. 12 minus 63, again, given that I've done my math correctly over here, 5 minus 2 is 3, 7 minus 1 is 6, and I just keep going. So 8, 63 minus 10 is 53, that would be 51, but a negative. I just multiply 8 times 51, negative 408. And I've got my sum. Now, the thing to keep in mind, though, is that they're not always going to give you that straight information where it's always just find the sum. They might turn that around on you a little bit, but keep in mind, they're getting you into the process here. But don't lose out on the fact that they might give you the sum, and you need to find the common difference. Do this same thing every time, and you will find the piece of information needed to finish the problem, okay? So it all starts with these two formulas. Now, last problem that we're going to take a look at is just an application. Now, don't lose the theme here. Your theme is that you're going to be using a sum of some sort. So keep that in mind, okay? All right, so in this case, you're looking at what would be slide 7. The center section of a concert hall has 15 seats in the first row and 2 additional seats in subsequent rows, okay? So that means the first row has 15 seats. The second row has 2 additional seats. The third row would have 2 additional seats. So notice that I've got a sequence going here, 15, 17, 19, 21, and so forth. What do we recognize? Okay, we should recognize we've got something arithmetic here. Now notice that it says how many people can be seated in the first 20 rows. So how many people in the first 20 rows? That means you need to find 20 rows. And all the people from row 1, plus all the people from row 2, all the people from row 3. We're essentially looking at adding all the way out to the 21st or the 20th row. So again, let's do the same thing. I'm going to write down my 2 formulas. A sub n is equal to a sub 1 plus n minus 1 times d. S sub n is equal to n over 2 a sub 1 plus a sub n. Okay, so I'm just giving myself my roadmaps. Let's identify what we have. Looks like we've got a sub 1, which is 15. Looks like we could identify d. Since we're 2 additional seats in every row, d is 2. We need 20 rows. So n has to be 20. So notice that if I start putting stuff in again, I need a sub 20, don't I? And again, put in what I know. S sub 20, 20 over 2, a sub 1 plus a sub 20. Notice that I can't calculate s sub 20 without a sub 20. Come to the other formula. A sub 20 is equal to a sub 1 plus 20 minus 1 times our d of 2. 15 plus 19 times 2. That's 15 plus 38. Looks like we have 53. 15 plus 8, or 5 plus 8 is 13. 13 plus, or excuse me, 10 plus 30. Is that 43? No, 53. 13, yeah, 53. Okay, sometimes I confuse myself too. That's okay. I'm getting old. But notice again, now I've got what I need to finish. So S sub 20. 20 over 2 is 10, and 15 plus 53. So it looks like 10 times, what do we have there? 68. So we get 680, but don't forget, application problem, get your label, 680 people, okay? So everybody, the big thing to notice here, these 2 formulas are the driving force to everything that you do within this assignment. Now keep in mind, you might be finding things that require you to find a term of a sequence knowing the sum. They might give you different pieces of information. But if you follow this idea, follow this theme, write down the 2 formulas, identify the pieces that you have and fill them in, one of them will give you a direction. And it'll lead you in the direction to get the other piece that you need. That will happen. All right, you're on your way, everybody. Take care. Good luck.